I'll be talking to you about LTE development today. Manish Wantwani was supposed to give this presentation, so you probably see his name on a lot of literature out there, but he was unable to make it, so I'm going to step in for him and kind of cover the presentation today. We're going to talk about why we need to accelerate or move to LTE and what are some of the advantages of LTE. With the agenda, we're going to talk about the cellular world we live in today, what is happening, what's happening with 2G and 3G and 4G. Talk about the LTE evolution, which is the division of LTE moving in two directions, the higher speed, the Category 6, Category 9, Category 11 technology, and then the secondary direction where we're moving to lower, Cat 1, Cat M1 narrowband IoT. We're also going to cover a lot of the advantages of LTE, what's happening with these new IoT, LTE technologies, which are going to make the adoption rate increase, and then talk about some of the challenges and how do we create a competitive advantage with LTE. So again, only 30 minutes today, but we'll try to get through a lot of good material. So talking about the cellular world we live in today. So we live in a world where there's 2G technology out there, 3G technology, and 4G technology. So there's actually three different generations of technology coexisting today. And so what does this mean? Where do we start? Where do we start new developments? Where should we focus? So the answer is a little bit different in different regions of the world, but in general, there's a couple of main points to this slide. One is that a generation of technology is only good for an infinite amount of time. When you look at 1G, which is the old analog technology, that started around 1980 and sunset around 2008. So it's available for about 28 years. As we look forward to 2G and 3G technology, that lifespan is about the same. 2G started back in the early 90s and going to run up until around this time where some network operators are starting to sunset that technology. 3G is still very prevalent around the world, and then 4G is starting to come specifically around IoT. So as we take a look at 2G, there is a sunset of the 2G network happening, but really that's focused more in the US and Australia. It's not a global phenomenon that 2G is going away. It's very specific to certain regions and certain operators around the world. So that's one thing to keep in mind. The other thing to keep in mind is that there is a limited lifespan on 3G. And the limited lifespan really varies depending what region you're in. Specifically in Europe and other parts of the world, there's considerations to sunset 3G ahead of 2G. So if you're doing deployments in parts of Europe, it still makes sense to use 2G technology rather than 3G technology. Another thing that's very important to understand is that LTE seems to be the common thread. So as you take a look at what's happening around the world, LTE is really the focus of IoT and new generations of developments that are starting to take place. And we'll talk about some of those competitive advantages today on why people are trying to find this common technology, which is really 4G LTE. So our LTE world, it's really been an amazing run with LTE. In the past, we had multiple competing technologies. We had the 3GPP GSM technology. We had 3GPP2, which was a CDMA technology. You had an IEEE WiMAX technology that came out for a little bit. But the world's kind of evolved and settled on one standards body, which is the 3GPP body, and they introduced LTE back in 2010. The specification was ratified in 2008. 2010, you see some commercial networks available, and now, 6 years later, there's almost 1.7 billion subscriptions out there. So really amazing growth from a technology. The kind of focus around LTE is led to some of these other technologies kind of fading away. You don't see a lot of 3GPP2 CDMA technologies being deployed anymore. WiMAX never had the momentum. Typically, they say if there's not 100 commercial networks out there, the ecosystem is not sustainable. We can see with LTE, there's over 500 networks available, so it's a very sustainable ecosystem. Everything from infrastructure to chipsets to modules to devices. So it's a very common global technology, which is really encouraging for our industry because we don't want to be doing a ton of different designs and using different technologies to deploy around the world. Beyond the 581 LTE networks, there's some advanced LTE networks. Lte-Advanced is the higher data speeds, so there's a subset of the 580 that support Lte-Advanced, Category 6 and above, and then a subset of the 580 that support VoLTE or Voice over LTE. And so that's going to be the same thing as we move to Cat M1 and narrowband 1. We'll start out with a subset of the 580 networks that support these technologies, and that'll grow over time. So what is happening with 3GPP in evolution from 2G GSM all the way up to 5G? Well, it's coming in different releases and different steps. And the main point of this slide is to show you that about every 12 to 18 months, there's a new 3GPP release out there. So release 13 is completed. It was ratified the middle of last year. The industry's working on release 14 and then release 15 and 16 and 17. And what happens is they get different terminologies for these different releases. So as we talked about release 8 introduced LTE, category 1 through 4, kind of the core LTE network was done in release 8 of the specification. Then Lte-Advanced really focused on releases 10, 11, 12. So if you heard the term Lte-Advanced, we talked about releases 10, 11, 12. Now they're doing release 13, 14, which is called Lte-Advanced Pro. So if you see any PR, any terminology around Lte-Advanced Pro, they're really talking about release 13, 14. And we talk about 5G, there's a lot of hype out there about 5G now. We're really talking release 15 and 16. So release 15 is the first ratified LTE spec is scheduled to complete around the middle of 2018. So in the middle of 2018, we'll have our first 5G specification that's should be available. So what is release 13 focused on? Mobile broadband. So again, LAA. I don't know if you guys heard of LAU, LTE unlicensed, or LAA, which is the LTE assisted access. So it's ways to use the 2.4 and some of these Wi-Fi bands to gain better bandwidth. So carrier aggregation using not only the licensed spectrum, but also the unlicensed spectrum that's available out there, 2.4 gig or other technologies. 32cc, currently in the specification, they support 5 different carriers for aggregation. Now with the release 13, they're going to do up to 32 carriers for aggregation, so ultra-wideband, ultra-high speed. And then some other stuff really focused around push-to-talk, around security with the D2D. On the IoT front, release 13 gave us Cat M1, narrowband IoT, and some of this eDRX, so extended DRX to save power consumption, but more importantly, it introduced Cat M1 and narrowband 1. So that was the big hype around release 13, which is pretty exciting. As we move forward to release 14, there's going to be some enhancements to LAA for ultra-wideband, high data speeds. LTE V2X. So V2X is vehicle to something, vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure. So the X can stand for a lot of things. But this is vehicle communication that's really focused on automated driving. And then from the IoT perspective, further enhancements in mobility, power save mode, higher data rates. So eventually we'll see not only Cat M1, we'll see category M2, M3, giving people different options out there. Potentially higher data rates or lower data rates, depending which direction they go. And then VoLTE. There's a big push in the industry to add voice over LTE support on the IoT branch with category M1. And then as we roll into 5G, 5G has some specific goals in mind, really focused on higher data rates. How do they get 1,000 times faster data speeds? Optimizing the Internet of Things is also a big thing. And so we'll talk about the timing and when they're going to be able to optimize the Internet of Things for mass deployments. What is the realistic timing? But what we see today for 5G is a lot of pre-standards. So the standards it's far enough along where there's some pre-5G testing happening today, really focused around the Olympic Games. So Korea is holding the 2018 Winter Olympic Games, so they're going to focus a lot around 5G, but again, pre-standard. And then same thing in Japan for the 2020 Summer Games. So you're going to see a lot of PR over the next couple of years about 5G, but it's really pre-standard. Approximate timing of commercial networks is really around 2020, 2021. You see the yellow triangle on top there. That's kind of our guess today when we'll see commercial networks available, phones being sold. Really, kind of turn, 2020, kind of that timing. So 5G realistic timelines. 5G is going to roll out in different stages. The fixed access, the pre-5G releases that you're going to see today is really fixed, high bandwidth devices out there. But over time, you're going to see enhanced mobile broadband, low latency for IoT, for drones, and for mission-critical devices. They're trying to get the latency down so they can have better user experience. And then eventually, more of a massive M10 IoT rollout. But that's not till probably 2025. So again, the focus for the next few years for new designs is really going to be around 4G LTE. So that's what we're going to focus on today. I keep showing this slide whenever I do a presentation because it's really impressive, the number of LTE devices that are on the market today, a number of subscriptions just in North America alone. We're talking almost 460 million subscriptions in North America, that's US and Canada, and 360 million people. So there's almost now 100 million more devices out there than people, which is really amazing. The phone market is very saturated at this point. There's now a lot of new growth. So the growth is really coming from IoT devices, secondary devices, anything from tablet, notebook computers, home alarms, meters, anything in the IoT space is really driving this growth. As far as the net growth, how many new devices are being added per year? It's around the 20, 25 million units per year is typically what we see. It's been the trend the last couple of years, increasing slightly each year. And it's also really important to understand that these legacy networks that we talked about early on in the presentation, 2G, 3G, CDMA, are really going away, and these numbers show it. So if you look on the right-hand side, you can see the year-over-year declines in number of subscriptions on CDMA. So we're talking the Verizon and Sprint networks. You know, they're moving their business off of CDMA over to LTE. AT&T, T-Mobile, others, same thing with the 2G and HSPA or UMTS. The number of subscriptions are going down as LTE continues to grow. It's a really amazing trend. I mean, the focus for M&O's investments is going to be around LTE. So as we look as an industry or an integrator, what technology to choose moving forward, it has to be LTE. You don't want to invest in older technology that's not going to be around forever and that people are no longer investing in. And so, you know, I run the application engineering team. I see a lot of designs. We try to help customers be successful. And all those designs we're supporting right now are LTE. We're doing absolutely very little support on any kind of new 3G design or CDMA design. It's really all focused around LTE. So the LTE evolution. So the LTE evolution is really interesting because we have LTE moving in two directions. In the past, we always used cell phone technology for IoT. We really kind of had to shoehorn it in there. We used technology designed for cell phones that would wake up every 1 second, look for an incoming voice call. Even though you had an IoT device, had nothing to do with voice, you still had to wake up every second, use your battery to look for a voice call coming in. We had devices that were getting more expensive rather than less expensive. We had devices that were requiring more components and getting larger. And so the LTE evolution is this new path on the lower side that we'll talk about. But the LTE evolution is not just the path downwards to lower size, cost, power, but also the path upwards to higher data speeds. And so everybody in the room has heard about Category 3, Category 4, Category 6, but it's been pushed up all the way to Category 16. I don't know if you guys have seen the recent announcement from Netgear and Telstra and Qualcomm, but they're doing a LTE Category 6 hotspot router box, which can do 1 gigabit per second over the LTE network. So really amazing things. So 1 gigabit per second, LTE Category 16 by Netgear, Qualcomm, and Telstra. On the secondary side, in the secondary LTE path, we have the lower technologies. So we have Cat 1, M1, and narrowband 1, and those are the technologies of today. IoT focused to reduce size, cost, power, and so a lot of the people and partners in this room are really interested in that second tier, this new evolution to the lower data speeds to expand their market, expand their reach. And there's a lot of new advantages that come with these new technologies. So as we talk about the general IoT path, what have we been following with LTE? LTE has been around since 2010. Adoption rate has been low because price points were very high. They had requirements for 2 antennas. It didn't make sense to move to LTE early on. That's starting to change. You guys see the numbers where legacy networks are going away. And so what has happened is the introduction of Cat 1. Cat 1 has always been in the network. As we take a look at those 580 networks out there in the world, they all support LTE Cat 1, 2, 3, and 4, so it's a common denominator that all LTE networks support. And so they're repurposing Cat 1 to kind of be the new entry-level IoT technology that's available today. So as you look into the market today, when people are shipping a lot of LTE devices this year, it's going to be a lot of Cat 1 devices into the market. Moving forward, Release 13 covers Cat M1. So M1 is really starting to become a reality. Telit has developed our Cat M1 modules. We've actually tested in the 4 live cities in the US. So the concept that we talked about over the last couple of years about this new IoT technology is finally here. We have parts, the ecosystem is starting to be built, and commercial deployments from customers are going to start end of this year, early next year. And then narrowband 1 is going to follow. We see network operators also gravitating towards narrowband 1 as an alternate technology to the traditional cellular that we've seen before. So what are the steps? I mean, the U.S. is really focused on Cat M1. What are the steps? How do we make this technology a reality? There's really 4 key partners that need to work together. There's the standards body, the network operators, the chipsets, the module guys. So we need to create technology that's sustainable, that's sellable, and so it takes input from all 4 of these different areas. From the standards side, they did their first part where they did the release of 3GPP release 13 was completed last year. They just completed the performance specs, so we now know how we can test LTE Cat M1. And now the industry working bodies like PTCRB and GCF are starting to figure out how do they add category M1 into their testing processes. So this is all in the works from the standards body. They're on the 3rd step, which is really good. Mobile network operators too, field trials, lab testing, customer pilots, those kind of activities have happened. So that's good. Limited market deployments are starting to happen. More and more cell towers are being lit up. More and more cities are going to come active over the next couple of months. Partners and customers can do field trials and pilots at larger scales. And then national deployments will be happening later this year. From chipset side, developing to the new specification, chipset certification, lab testing, these are the activities that are happening now with the LTE Cat M1 chipset suppliers. And then commercial availability is going to happen a little bit later this year too. So again, we're at the point in the industry where it's not on paper, it's actually happening in reality. From module perspective, module designs are being completed. Sampling, Telit and others are starting to sample Cat M1 products out there in the marketplace for these customer trials. And then mass production of Cat M1 products happen later this year. And we see really customers starting to ramp those at the end of this year or into next year. So we talked about how we're all kind of settling on this LTE standard, release 13, 3GPP, everything sounds great. There's no more CDMA, there's no more IEEE, WiMAX. So everything sounds great, but in the end, what happened with release 13 is there's 2 competing standards that have different use cases. So there was category M1 and narrowband 1, which are slightly different and kind of address different market needs. So the standard actually has 2 technologies, and so as networks around the world deploy these new technologies, they have to select one typically to be that lead technology. And so what we're showing here is, as we look up in Canada, most likely Canada is going to focus more on narrowband 1 or Cat M1, and a lot of it's to do with what infrastructure they have, what core network they have. In Canada, there's a lot of Huawei infrastructure, and Huawei, from an infrastructure provider, is really focused on narrowband 1 first. As you move into the U.S., you see all the public announcements. The big MNOs are focused on Cat M1 first. That's infrastructure from typically Ericsson and Nokia, and Ericsson and Nokia are really focused around M1 first. And so if you're in the U.S., your least path of resistance is going M1 first. Europe's a little bit fragmented, but there's mainly narrowband 1. Again, a lot of Huawei infrastructure. And you see some MNOs also going with Cat M1. So there's a little bit of fragmentation over there in the short term. Australia is pretty unique because they're trying to deploy both at the same time. So they're kind of shaded. And eventually, I picture the whole world kind of being shaded in both M1 and narrowband 1, but it's going to take some time. Right here, we're trying to show the lead technology choices for each region. Again, over time, this is going to evolve. We envision M1 and narrowband 1 being readily available in the US, Canada, Europe, and other parts of the world, but it's going to be one step at a time. And then as we get into China and Korea, there's a focus around narrowband 1. So again, it's a lot to do with the infrastructure. It's a lot to do what technologies they're replacing. For example, today Cat M1 and narrowband 1 do not support voice. Well, when you look at Europe, 2G network supports voice, and it's going to be there for a long time. And so they felt they need to go with the lowest end technology first, so they really pushed for narrowband 1 ahead of M1 because they were using GSM as kind of their M1 for the short term. So it really depends on the market needs and infrastructure providers in order to determine what technology was lead for each region. So technology selection for new designs today, there's really 2 options out there. Again, we talked about how there's not a lot of new designs happening in 2G or 3G. It's really around LTE. There's LTE Category 1, pretty much globally available. So there's 580 networks support LTE Cat 1. Voice support, so if your application requires voice, it's a great option. The downside requires two antennas for optimal coverage. So again, that's what's available today. That's what we see a lot of people moving in the direction. It's a sure technology. It's out there. There's no risk associated with it. On the other side, the other option is going to be Cat M1, narrowband 1, which is a new technology. Again, networks are just being deployed and tested now. It's going to take some time for that to become very stable and commercialized. But the advantages of narrowband 1 and M1 is reducing the size, cost, power, the use of single antenna and single coverage. So we finally get some of these IoT needs that we've been asking for the last 10 years are finally coming a reality. So again, as we're looking at new designs, we will consult, work with partners to determine which is the best technology for them. Today, we still see a lot of Cat 1 designs being started because it's a sure thing. The network's there. It's tested. It's low risk. And we see other people kind of waiting out for M1. They may bridge at 3G, skip LTE Cat 1 and go to M1. But there's some unknown timings in that scenario. As far as what's different, I touched on it quickly. Cat 1 still has very good data speeds. 5 megabits up, 10 megabits down. Downside is required 2 antennas to get full coverage. There's a lot of options out there for single antenna, but it does impact your coverage. So that's something to keep in mind. If you're an outdoor device with an outdoor or a mag-mount antenna, it may be fine to use single antenna. If you're located in a building, if you're a security system, then probably the use of one antenna doesn't make a lot of sense. Supports mobility and voice, so it's the standard cellular network that we've grown to use and love. Supports power save mode, so it does support some advancements from Release 12 in PSM mode. Supports firmware over there updating. So it's kind of the core cellular technology that's being used today. Moving forward with the Release 13, half duplex systems that are going to do around 375 kilobits per second. So again, lower data speeds than Cat 1, but still pretty good data speeds for the typical IoT application. Single antenna, which is a big thing for a lot of mechanical packaging and installations. Mobility, full mobility, some coverage gains with Mode A, 5 to 10 dB enhancements. When you talk about 6 dB coverage gain, it can be pretty significant. Instead of a cell tower, say, covering 6 miles, 6 dB more in free space gets it up to 12-mile radius. So you're talking about doubling coverage radius, which is increasing the coverage area by 4 times. Firmware over there will be supported. Some enhanced power save modes with both PSM and EDRX will be supported. And then with narrowband 1, kind of the same kind of tone where really focused on the very low end, single antenna, supports extended coverage. Extended coverage is even further because it reduces the bandwidth even farther. So it doesn't support 375 kilobits, but closer to 20 kilobits per second, very low end, very focused on sensors. So there's some definite differentiators between the three. As you look into U.S. deployments, the options today are Cat 1 or Cat M1. Not going to spend a lot of time on power save mode, but power save mode is a Release 12 feature that really focuses on how do you reduce power consumption of the device. Today, everything wakes up, 2G and 3G wakes up every 1 second looking for incoming voice call. That's not very effective for power or battery-operated devices. And so Release 12 and power save mode is a way to extend batteries up to 1,000 times by, instead of waking up every second, you can wake up for short periods of time and then go to sleep for long periods of time. So very focused on mobile-originated communication devices, but it is something that is being deployed now and being supported by Telit. When it comes to EDRX, this is a Release 13, so it's a more elegant solution where you never lose sync with the network for long periods of time. You can vary how often you sync with the network, everything from a second up to 44 minutes, and you can dynamically allocate that. So instead of the network telling us what to do, with this new generations of IoT technology, we're in charge. We're telling the network how we want to perform. So it's giving the device more power to be more successful on the network. So it's a big handoff from the network operators and infrastructure and the standards telling, hey, this is how you have to perform. Now we're asking for requests. We want to perform with this quality service. We want to wake up this often. And the network's being able to adapt to that to really help our business cases succeed. And then extended coverage. This is another very important point. The big thing that we want to do is increase the RF link budget. The link budget on cellular has been good, but not great. How many times you go into a basement, you have no coverage? How many times you go into a parking garage and have no coverage? And so one of the things that the IoT working group really focused on in 3GPP was extending the RF link budget to get the best coverage possible And so with typical LTE, you have 140 dB link budget, RF link budget. This is increased with Cat M1, has different modes, mode A, mode B, and then narrowband. So again, there's different variations of increase. But again, the way you should think of it is every 6 dB of increase doubles the cell radius. So it's pretty significant. So now you can get the coverage in building, in ground. If you're going to bury something in a pit in the ground, if you're going to bury something inside a vending machine, if you're going to bury something in a basement, it can now be done more successfully. We have too many situations where people want to use cellular, and they can't because they can't get coverage. They're trying to run antennas out of a building. They're drilling holes through brick walls. It's not really a good solution to have ease of installment. I mean, the advantages of cellular are great. I always go back to the Kindle story. You can deploy, say Wi-Fi or cellular, and if you have to do a mass deployment, Wi-Fi can be difficult because you have to figure out where the hotspot is. You have to put the password in. The user experience is not always great. Installation can take longer. With cellular, it's out of box, powered up, it works. It connects to the network. So there's not a lot of configuration options or management that is needed. And so by increasing the link budget, we think it's just going to be even an easier install process for IoT rather than having to figure out if you have coverage or what network operator is the best coverage in a given location. So we talk about the different LTE categories. Different categories, actually 3 to 16 now. There's different segments and devices that need this type of high data speeds. So on the high end, there's definitely a market out there, everything from automotive to routers to phones. Category 1 is a big market because of voice, so security or PERS, landline replacement. Cat M1 is going to be really good for track and trace, point of sales, and different vertical markets. So again, the main point of this slide is all these different technologies have a place. Not everybody is going to settle on narrowband 1, or not everybody's going to settle on Cat M1. Depending on what your needs are, there's better technology selection available today, and that's the key message here. I personally think if you're using cellular today to some capacity, you're probably going to stop at M1. M1 is the cellular technology that we've used over the last many years that we've become accustomed to, where narrowband 1, in my opinion, is for new market opportunities that we haven't addressed yet. So new market opportunities that are not using cellular today now have an option to potentially use cellular because of what the advantages of narrowband 1 bring. And so as we take a look at what is using licensed spectrum give you, a lot of times in the past to get these low power wide area networks, you had to use unlicensed spectrum, 433, 915, 2.4 gigs. You could get jammed. There could be a lot of interference. There's a lot of uncertainty there if you're a Fortune 500 company, you're trying to deploy an enterprise-grade solution. And so what's happening with M1 and narrowband 1, you now have licensed spectrum, which the MNOs can control. They can provide SLAs, quality of service, security coverage, all these things that are not readily available in the unlicensed spectrum. And so this is one of the things that the industry is pushing, is they're not saying that M1 or narrowband 1 is going to replace all these other technologies. It now becomes an option. As you're looking at what kind of technology you should use for your business, cellular is now becoming an option where it was never in the past. And it helps you overcome some of these hurdles you had to face and technology challenges. So why move to LTE? I think we touched on a lot of these areas. Legacy technologies are going away. Legacy technologies, whether it's 2G in US or 3G in Europe, are not going to be there forever. The ecosystem and sustainability is really, really important. Whenever Telit does a module design or invest in a technology, we want to make sure we can support that technology for the next 10 to 15 years. And so we have to take a look at the ecosystem. And if we're trying to focus on WiMAX, which doesn't have enough networks out there or doesn't have enough money backing it, it's a big risky move. And so from our standpoint, LT has done a great job with the 580 networks and continuing to grow. That's a very sustainable ecosystem that's going to really help everybody be successful. The advancements in size, cost, power, you're going to hear me say size, cost, power a lot, but it's really, really important to understand what this technology is going to do for you. This is not the old technology that we had to put up with the last 10 years. This is new technology, really focused around our needs. The IoT industry is big enough now where we have enough momentum where we can dictate what goes into the standard. So it's very, very encouraging. New features, new market opportunities. I think the biggest thing that when I talk to partners on is, okay, you have these new features, extended coverage, controlling power consumption, battery life, how you interact with the network. start thinking about how you can write some IP around it. How do you create a competitive advantage? And so from the Telit side, we can sit down with you and say, okay, what are you doing? Let's think about using the technology in this way. Maybe you can file some patents or disclosures or whatever it may be to try to create a competitive advantage. And that's one thing that my team is focused on, is how do we help Telit partners succeed and really succeed in a big way. Because in the past, there was not a lot of competitive advantage. Everybody's using the same CDMA technology, so everybody had the same battery life. Now there's ways to vary it based on different algorithms. And then the technology trade-offs. What technology is right for you? Is a Cat 1, which again, most people are still designing around, I think is going to be the really workhorse for IoT over the next 3 or 4 years. Or you got to wait for Cat M1 because your business case requires super low power that Cat 1 can't give you. Timing and availability. Do you have to get to market this year or next year? That's really important in deciding what technology you go with. Is voice required, battery powered? So again, we have to take a look at all these different things to determine what's the right technology for you. And what we do at Telit is we're very consultative. So you come to us with what you're trying to do. We will work with you to try to put you in the right technology to make sure your business is a success. And so I'm about running out of time here, but what is Telit doing? We are focused on a global portfolio of IoT modules. So we're launching Cat M1 modules for US. We have 4 different modules now that we're sampling that are ready for prime time. We have a selection of narrowband 1 modules for other parts of the world, for Korea, Japan, Europe. So we put a big investment in Cat 1, M1, and narrowband 1, because that's really where we see the future going. And so we have a complete product portfolio to allow you to scale your business and not have to just worry about what's going to happen in one region of the world. The whole value around Telit is to remove your risk with selecting technology. And we're large enough where we can do all the different relevant technologies for all the regions. So if you don't know if you want to go Cat 1 or M1 today, it doesn't matter with Telit. You can do a single design. You can build half and half, do your testing, and then make your decision 3 months down the road. So what kind of partner can you work with? You say you don't need a technology selection today. You can push that 3 years down the road if you work with Telit. So it's a very powerful message out there. We're not trying to pick winners or losers, whether it's Cat 1 or M1 or narrowband 1. We're embracing all 3, and we got a very strong global portfolio to show it.